Let's begin today's session. In last session, we already discussed about a rolling motion. Now, in today's session, final velocity, we're going to discuss final velocity of a body, of a body, final velocity of a body at the bottom or the end of a inclined plane, at the bottom or end of an inclined plane, inclined say plane, right? For example, let's take example. If we suppose to have a such a inclined plane, and the inclination of that particular plane is theta, means that if that particular plane is like this, and now it is going to incline by certain angle. So we suppose to have such a inclined plane, right? And we are going to place any object. You can take any symmetric object. Any symmetric object. That means what kind of object would be it is? It may be a sphere, right? It may be a say ring. It may be a say cylinder. It may be, we can say that you can take a rod also. You can also disc. You can take a disc too. So these are nothing but we can say that different kind of symmetric object that we can place at the top of the object. Now it is going to roll down, and we are quite aware that if object is a rolling, that means within a rolling motion there are the two kind of motion. One is translatory motion plus rotatory motion. So this, we can say that when object is supposed to rolling down in an inclined plane or on an inclined plane, that time object supposed to substitute object supposed to, we can say that for this two kind of motion. One is translatory motion, and the second one is, we can say that rotatory motion, right? So we wanted to find out final velocity. What we wanted to calculate here, final velocity. For example, at the top of that particular inclined plane, the velocity of the object say is equals to 0. Now the height at which object is situated at the top, that height I am going to take, that is equals to h. So from the bottom to the top, we can say that top, the height is, we can say that h, right? And the total displacement of that particular that object from top to bottom, that displacement I'm going to take a s. So the distance traveled by the object from top to bottom is equal to s, right? Now we wanted to apply, what we wanted to apply, so that is the key point of this particular derivation, that is nothing but a law of conservation of energy. We need to use law of conservation of energy in this particular derivation. So what law of conservation of energy says or states, that is, in a total kinetic energy of the system, or the total energy of the system remains conserved, means energy neither be created, energy nor be destroyed. It can be transferred from one form to other, right? So in other word, in mathematically you can say that total energy at top, that means initial total energy at the top will be is equals to total energy at the bottom, because we considered that the motion starts from the top and which ends at the bottom. So that is the case we need to consider. So total energy, that means potential energy at the, we can say that bottom, at the top, and plus kinetic energy at the say top will be is equal to total energy at the bottom. That means potential energy plus kinetic energy, but we are going to consider total energy at the bottom. That's the reason why this potential energy at the we can say that bottom, and this kinetic energy at the bottom, right? Now what is the potential energy at the particular height h? For example, let's take an example. Say this is nothing but a ground. We can say that ground, right? And from the ground, if the object we are going to keep at a particular say height h, then the potential energy possessed by the body is equal to mass of that body into G into S. So that is nothing but potential energy at the top. Plus, if the object is at rest, that means its kinetic energy will be is equal to 0. Why kinetic energy will be is equal to 0? Because the kinetic energy is nothing but a, we can say that kinetic energy is nothing but a what? It is the product of, instead of 0, I'm going to write down kinetic energy at the top, that will be equal to 1 by 2 mass into its velocity at the, we can say that top, 1 by 2 mu square, that will be equal to m into G into H, that is the potential energy at the bottom. So, but the potential energy at the bottom will be equal to 0. Why it will be 0? Because H will be 0 over there, right? So that's the reason why mgh I'm going to take, and H will be 0 in the case of bottom. Plus kinetic energy is equal to 1 by 2. If the mass of the object is m and the velocity at the bottom will be equal to v, then kinetic energy will be equal to 1 by 2 mv square. This is the situation here we have. Let's try to understand this particular statement again. What do you mean by law of conservation of energy? That is nothing but a total energy. Total energy, that means what we have in a total energy. In a total energy, we supposed to have a, say, potential energy plus kinetic energy. This factor together, addition of this factor together is called as the total energy, right? So total energy at the top will be equal to potential energy at the top plus kinetic energy at the top. What is the total energy at the bottom, or the final we can say the total energy that will be equal to potential energy at the bottom plus kinetic energy at the bottom, and we place the value of potential energy and kinetic energy at the top, potential energy and kinetic energy at the bottom. That is a simple kind of derivation here we have. Okay, I'll write down again that particular equation, right? So now potential energy at the top will be is equal to m into G into H. Kinetic energy there will be equal to 0, because we can say that over there velocity at the top will be equal to 0. That will be is equal to then potential energy at the bottom, that will be is equal to 0 plus we can say that kinetic energy at the bottom. But the kinetic energy, not only we need to take 1 by 2 mv square, because object is not only translating but also it is we can say that it is also rotating. So we need to consider rotational kinetic energy also, 1 by 2 I omega square. So in a previous equation, what we need to add over here, kinetic energy at the bottom means translational kinetic energy plus rotational kinetic energy 1 by 2 I omega square. This factor we need to add over here. We need to add in the last term this factor, right? So we can say that total kinetic energy at the bottom will be is equal to kinetic energy due to translatory motion plus kinetic energy due to rotatory motion, right? So this is the situation here we have. Now m into G into H will be is equals to this 0 we are not going to consider, this 0 also we need not to consider. What will remain over there? 1 by 2 m v square plus 1 by 2 I omega square. Now instead of, we can say that instead of I, you can write down, instead of I you can write down that is equals to m into k square, and instead of v also you can put the r omega square, but we wanted to calculate the value for the velocity. So what I'm going to do over there, so mgh I'm keeping as it is, m into G into H, we can place the H value little later, plus 1 by 2 mv square as it is, mv square as it is, plus 1 by 2. Instead of I over here, I'm going to place this value, that is 1 by 2 as it is, instead of I, mk square into this omega square as it is, into this omega square as it is. This m and this m, that all we can say that masses will get cancelled. So what will remain over here? GH will be is equals to 1 by 2 as it is, only v square will remain as it is, plus 1 by 2 k square omega square, 1 by 2 k square omega square. So we can take this two common, and we can say that multiply that particular that side. Means what? Let's say take 1 by 2 common, right? What will remain in the bracket? V square plus k square omega square, right? Take a 2 to this side, that will become twice gh, right? So this gh will be as it is. Take 2 to this side, it will become twice of gh, that will be is equal to v square plus k square omega square, right? But still we wanted to calculate for the equation, some certain equation would be supposed to be there. So what is the value here we can apply over here? So the simple aspect is here, instead of omega plus v upon r. Why? Because v is equal to r omega, right? So as v is equal to r omega, so omega is equal to v upon r. If I place over here, so if I wanted to take a square, because omega square over there, so I'm just squaring on both sides, right? So by placing the omega square over here, so what you will get, that is equal to twice gh, v square will be as it is, k square will be as it is. Now instead of omega square, I'm going to place v square upon r square over there and take a v square common. Even in the last term, in the this term also we can do everything. So that is easy we can say that way. So take a v square common, what will remain? 1 plus k square upon r square over there, and that is equals to twice gh, right? So what is the next step over there? The next step will be is equal to take whole bracket to this side, right? And as if we are going to take a whole bracket to that side, what will going to happen over there? But twice gh will be as it is, divided by 1 plus k square upon r square will be as it is, will be is equals to v square, and taking square root on both sides you will get a v. So v will be is equal, and square root of this term, that means raised to 1 by 2. That what is term will be remain over there, that is twice gh upon 1 plus k square upon r square. This is the simplest aspect. In a 2 to 3 term also you can solve this equation. Whatever the equation I said to you, within a we can say that 2 to 3 step you can do like that. Means here also you can place directly omega is square equal to v square upon r, right? V square upon r square, and you can simplify this particular. This no need to go with this much of, we can say that bigger explanation. Within a 1 to 2 step only you can solve that particular term. So how to solve that? I'll write this equation again. I'll write that equation again. So what was the equation over there? Mgh will be is equals to, what is that? Mgh will be is equals to, say, 1 by 2 mv square plus 1 by 2 I omega square. This is the term here we have, right? Now instead of this mm will get cancelled, only gh will remain. 1 by 2 v square will be as it is, 1 by 2 as it is. Instead of I, m r square, instead of omega, mk square, instead of omega v square upon r square. So directly I place the value of I and omega in this term only. So within a one single term you will have all derivation, complete derivation. So gh will be equal to 1 by 2 v square plus 1 by 2, if we take a 1 by 2 v square, 1 by 2 v square common from this particular term, 1 by 2 v square and 1 by 2 v square common, this m will not be there, right? So what will remain over there? So instead of this gh, I'm going to write down again 1 by 2 v square, you can take a common, so in bracket 1 plus k square upon r square will remain. So within a we can say that single term only you got the final equation. So that is easy way. You will get v square, 2 will go to this side, and this bracket will get divided to gh. That is equal to 1 plus k square upon r square. So this is the situation here we have. It is quite easy. Okay, after simplifying this particular term, sometimes some students supposed to have certain say derivation, some we can say that problem, that so you just wrote over here v square on the right hand side, now you are just writing that this particular term on the left hand side. Is it possible? Yes, it can be possible, no issue with that. So you can write down like that. So taking square root on both sides, taking square root on both sides. So taking square root on both sides, what you will get? Square and square root will get cancelled. So it will remain v square only. Twice gh upon 1 plus 1 plus k square upon r square, and the square root of this term, that means raised to 1 by 2, or directly you can write down in the square root equation like that. You can say, miss, instead of 1 by 2, instead of 1 by 2 you can take a direct square root sign, or directly you can take the power of that particular term raised to 1 by 2. Okay, so this is the situation here we have. This is all about, we can say that, velocity of a that particular body at the bottom. So velocity is depend on a k, velocity is depend on a r. So if object we supposed to have a two disk, for example, there is a two disk. So first disk supposed to have the radius smaller, and now the second disk supposed to say this is nothing but a twice r. It doesn't look like the twice r, but just consider that if the radius of the first disk is r and the radius of the second disk is nothing but a twice r, which disk, first disk or the second disk, supposed to be have a higher speed? Which disk supposed to have a higher speed, the of a radius twice r or of a radius r only? Next point, acceleration of a body on inclined plane, acceleration of body on a inclined plane. Now we wanted to calculate acceleration, right? So I'm just going to draw that inclined plane again, right? An inclined plane will be like this, theta is like this, this is, say, this height will be of that particular inclined plane is, say, h, right? The displacement of that body is equal to, say, s. Then in this particular case you can write down sine theta will be is equal to h upon s. Sine theta, opposite side upon hypotenuse, this is equal to 90, right? So that means h you will get, h will be is equals to, h will be is equal, s will get multiplied to the sine theta, s sine theta. Instead of s you can take a l also, instead of s you can take a x also. By, now we wanted to calculate acceleration, so by third kinematic equation, third kinematic equation, by third kinematic equation, what we can say that v square minus u square equal to twice of as. V square minus u square equal to twice as. So v is the velocity, and final velocity we already calculate. What was the velocity? That is equal to twice gh upon, we can say that, 1 plus k square upon r square. This velocity already we discovered, minus initial velocity at the top, that is equal to 0. That will be equal to twice of a into s. Now we wanted to calculate acceleration, so keep acceleration on this side, take a 2 and s to another side. So what we will get over there, what will remain over there, acceleration will be remain as it is, this 2 gh will be remain as it is, this 2 into s will get divided, 2 into s will get divided, in bracket this 1 plus k square upon r square will remain as it is, k square, that term will remain as it is. These two will get cancelled. So what acceleration here we have, acceleration will be is equals to g into h divided by 1 s into 1 plus k square upon r square, something we will supposed to get over there. So as if here we'll supposed to have such a situation, you can place the value of h like this. What will be the value of h over there? So let's rewrite this particular equation. I'm going to write them over here, right? So what is a? A will be is equals to, g will be as it is. Instead of h, what you can place, instead of h you can place s sine theta, s into sine theta, right? Whole divided by s into 1 plus k square upon r square, k square upon r square, right? So what will cancel, s will get cancelled, what will remain only there, a will be is equals to g into sine theta upon 1 plus k square upon r square. So the final term, final acceleration over there, acceleration a will be is equals to g into sine theta upon in in a bracket 1 plus k square upon r square. So this is nothing but a acceleration of the body on a inclined plane. This is simple, we can say that derivation, right? So this is quite easy, quite easy, we can say.
Sir,